Hello again, this is another video on the control charts, and in this video we'll be talking about the P and C charts. And if you remember, we did talk about these are for the attributes charts, and whenever we have a yes or no, pass or fail, we could use these kind of attribute charts. So now let's talk about the P chart in particular and when we use the P chart. We use the P chart for quality characteristics that are discrete and involve yes, no, or good or bad decisions, uh, such as the number of broken eggs in a carton. However, the C chart is for the discrete defects when there can be more than one defect per unit. Okay, so if we have a more than one defect per unit, that would be a C chart. If there's only one defect in a unit and a yes or no, good or bad, that would be a P chart. Again, remember the C chart has when you have a more than one defect per unit, such as number of flaws or stains in a carpet sample cut from a production run, or number of complaints per customer in a hotel. So if you can find more than one defect in a one unit, that would be a C chart. If there is a yes or no and one defect for a unit, that would be a P chart. All right, let's take an example and see how we could do the calculation and what equations we use. A production manager for a tire company has inspected the number of defective tires in 5 random samples with 20 tires in each sample. The table below shows the number of defective tires in each sample of 20. Calculate the control limits. So sample number one, we did inspected 20 of the tires. We found 3 of them are defective. We can't use it. Uh, Sample 2, we have found 2. Sample 3, we found 1 defective tire. Sample 4, we have found 2 defective tires. 5, only 1 tire that is defective and cannot be used. So let's take a look into the equations. So whenever we talk about control charts, remember you need 3 things: control line, upper control limit, and lower control limit. For the center line, the CL would be calculated by finding the total number of defectives, 3 plus 2 plus 1 plus 2 plus 1, that would be equal to 9. Total inspected, how many total inspected? 100. So 9 divided by 100, that would be 9%, or 0.09 as a center line. Now let's calculate the sigma, the standard deviation for the process. The standard deviation for the process would be P times 1 minus P, the average, divided by N, all to the square root. So for this particular example, 0.9 times 1 minus 0.9, which is 91, divided by 20 to the square root, and that would give you 0.064. The upper control limit would be P, the average of the defective, which is the center line, plus 3 or minus 3 sigma for the upper control limit or lower control limit. And that would give you 0.282 for the upper control limit and negative 1.02. And however, there's no way that you could get a negative in a control charts. Whenever you see a negative, right away change it to a 0. Change it to a 0. And now you're ready to go plot the chart on using these values. We'll take an example to show you how we could plot these values. I'm going to stop the sharing now here, and I will be sharing my Excel with you. All right, guys, now we're going to share this Excel here. So I took the data and I put it on Excel. So again, this is a template. I took this activity here from the templates that I provided on D2L and modify it to fit the data. So we have 5 samples. Each sample we have 20 tires inspected. We find 3, 2, 1, 2, and 1. Exactly the same thing what we have here on the slides. Just to double check, 3, 2, 1, 2, and 1. Okay, and now the first thing you want to do, again, in control chart, you need three things: center line, upper control limit, and lower control limit. So for the center line, you need to find the average of the P. So in order to find the P, you have to find out what would be the defective, which would be for each one of the samples. So that would be 3 divided by 20. Same thing here, 2 divided by 20, 1 divided by 20, 2 divided by 20, and 1 divided by 20. So we have found the uh, uh, P for each of these samples. What would be the percentage? Basically, what is the P? It's the percentage of the defective for each sample. So 3 divided by 20, that would give you 15% as a defective parts of that sample. So now what we need to do, we need to find out what would be the average of the defective, which would be number of the defectives. Add these together, that would be 9. Adding these number 3 plus 2 plus 1 plus 2 plus 1, and divided by the total inspected. So that would be 9% expected to have a defective in your production line here. So the P bar, which is the average of the percentage, defective percentage, would be 9.09. Now for the sigma, now the next step, we need to find out what would be the sigma. And I'm following these equations. Second equation would be finding the standard deviation for the process, the square root. There's a function in Excel called square root times P average, which is 0.01. P is not 0.1 here. It would be 0.09 minus times 1 minus 0.09 again, and that would give you 0.064. 0.064. Yep, that's what we got here, as you see from the equation. Again, a square root of the P average times 1 minus the P average divided by N. And here for the N, not the total inspected, but the sample size for each sample, which is 20. All right, 64, 0.064. And now the center line would be the P bar, which is the average of the defective percentage. The lower control limit would be P average minus 3 times the sigma, and that would give you a negative value. Right away, what you need to do is change it to a 0. Upper control limit is the P average, which is 0.09, plus 3 times the sigma, which is 0.064, and that will give you 0.282. Now let's go create the charts using this table right here, starting with the center line. The center line would be equal to this value here, 0.09, and then double click or scroll, drag it all the way down. Lower control limit, we know that this is going to be 0, so we did calculate that. Upper control limit is taken from this here, and lock the cell by adding the $ before and after, and now copy the cell for the rest. And for the percentage of defects on each sample, it's going to be taken from here. And now, as you see, look at the chart. We have an upper control limit, lower control limit. We have a center line, and the first dot, the first point has been established here. And now let's do the same thing. And now we found out, we created the P chart for this activity. First of all, why we did P chart? Because this is only, the item can have only one defect. It's a yes or no. You can't have more than two defects, more than one defects in one item. That's why we used P chart. Now we're going to move to a C chart. We're going to talk about the C chart, but I'm going to leave it to another activity, to another video, and we'll do another activity for that video. With that said, I'll see you in another video on the C chart.